Alright, so the first example I want to run through for exercise 3D, solving trigonometric equations or circular functions. So we've kind of learnt all of this stuff in methods, but the only difference in specialist is we mix it up a bit and try and confuse you as much as we possibly can, because that's what they love to do in spec. So we start to throw in things like cot, sec, cosec, and also inverse circular functions as well. Let's have a look at this one, which is cot. Now I'm going to solve this two different ways. I'm going to use the general formula, and I'm also going to use what we've probably done in method. So the first thing I'm going to do is I'm going to write cot as 1 over tan x, and that equals negative root 3. And then I can say, all right, tan x is equal to 1 over negative root 3. And what we did previously is we would solve this for a reference angle and ignore the negative. And then that reference angle is, I'd say, okay, when is tan theta equal to 1 on root 3? And that was at pi on 6. So this is my reference angle. I'll just put that here, reference angle. And what I've encouraged you to do previously is to draw the unit circle and say, okay, pi on 6 is down here. By symmetry, there's another point here, here, and here. And the two quadrants where tan is negative is in here and in here. So this first solution, there's one, I'll use a different colour. There is 1 pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, 5 pi on 6, 6 pi on 6, 7 pi on 6, 8 pi on 6, 9 pi on 6, 10 pi on 6, 11 pi on 6. And they are my two solutions that have negative 1 on root 3 in the unit circle. So I would go back up and I'd say, right, x, don't know why I put the brackets in, x is equal to 5 pi on 6 and 11 pi on 6. And I've got my two solutions. But what I want to show you, because this will come in handy later on, is we can use the general solution. So if I go back to this point right here, and I work with this point right here. Okay, I'm just going to rewrite that. Tan x equals negative 1 on root 3. So then I can go and say, all right, well, x equals, and I'm going to use the general formula, which is n pi plus tan to the minus 1 of negative 1 on root 3. Okay, I still have to get my first solution for this part here, but I quickly work out that the inverse of tan of 1 on root 3 is pi on 6. So tan to the minus 1, or inverse tan of negative 1 on root 3, is negative pi on 6. And here's my general solution. What this does is it tells me every possible answer where n is an integer, or n is an element of z. All right. Now, how does this give me those two answers that I got before? Well, it's just a matter of substituting in some values for n. So if n equals 0, then x equals 0 pi minus pi on 6, which equals minus pi on 6. This one, not in the range that we were given. Okay, n equals 1. x equals pi minus pi on 6, which equals 5 pi on 6, tick, there's one of our solutions. If n equals 2, then x equals 2 pi minus pi on 6, which equals 11 pi on 6, tick, that was in our range. If n equals 3, x equals 3 pi minus pi on 6, which is 17 pi on 6. It's not in our range. If n equaled minus 1, x equals minus pi on 6, which is minus 7 pi on 6. Again, not in our range, but you can see that this is a pretty quick and effective way for finding lots of solutions, and it's probably easier than what we've been doing previously in methods to solve trig equations. So nifty trick, couple of rules there for you to try and remember to speed up your solving trig equations.